Hello and welcome to the fourth in our series of demonstration videos for the VPAT product. In this video, we're going to look at the analyze function in VPAT and specifically at the workload performance analysis functionality. So let's start this video where we left the last one off, and we're going to click on the graph button next to the Gen CPs and workload report file row, and we're going to bring up service class information. So we're going to tell it to pick from the prod 3 LPAR. And this is the chart showing where all of our CPU usage is going by service class. Now let's return back real quick and just review one option. We have selected 0% for our minimum utilization for graphing. If I were to put 2% in here and click on the same graph, and we select prod 3 again, we'll notice that we have fewer service classes here. And that's because anything below 2% utilization has been suppressed out of the chart. For our purposes and for this demonstration, we're going to put in a 0 here. And we're now going to click on graph. Now, in our prior videos, we showed how we could select by date in the x-axis and drill down into the graph as we desire. In this situation, we're going to click on the 2/12 date, and we're going to look at February 12th, and we're now looking at all of our service class data. And what we're going to see here is that we're going to click on the CICS medium on the 12th, and we can see a mouse over display that we are in fact in the CICS medium workload, the light blue. So we're going to double click this time. In our prior, we single click to get the mouse over display. Here we're going to double click. And what VPAT is going to do is it's going to create something called the workload performance table. And when we click within the chart, VPAT is actually going to take us to the date and time offset that we selected within the chart. Now, by scrolling right and left in this data, you can see what VPAT has assembled. And basically, we have many usage data, CPU usage data, CPU usage by and our machine as a total, our LPAR, zip engines, what our workload, our CICS medium service class is using, how much our total delay is, and we can see many other delay characteristics, as well as some other numbers such as start subchannel rate, transaction response times. So by scrolling right and left, we can see these. We can also scroll up and down, and we can see earlier or later intervals. So let's go back to the chart for a moment, though. And let's this time deselect everything, and let's just look at CICS TOR. Now, you can see usage is very low on CICS TOR, and we can see that it's very difficult to try to click on this. So to make that easier, let's show another way to get to the workload performance table. We'll return back, and this time from the main analyze panel, we're going to select the run option. And we'll click in here. We're going to select our prod 3 LPAR. And now we're going to select what service class we want to look at, which is CICS TOR. And now we're going to run. And we'll see that we're in the workload performance table now for the CICS TOR service class. Since we opened it up through the run option, we're at the beginning of the data. If we had double clicked, we would be at some displacement within the service class's data. So if we look at this, we can see that VPAT is going to color code some of the intervals for us. And this is a color coding based on total delay and achieved execution velocity. And this may represent potential performance issues. Doesn't always represent that, but you'll have to understand your shop and the specifics of your workload, as we'll see later on. But they may have potential performance issues. So let's go back to the graph and let's select that CICS medium again. Let's go back to the run option here. And we'll look at CICS medium this time again, and we're going to say run. And now we're going to scroll forward to February 12th at 1959, where we know we have some performance issue. We can see various color coding for the intervals that are going by. And we can see that we're going to arrive at 1959 here. And we can see that there is some potential performance issue that VPAT has identified and color-coded it in red. And if we look here, we can see that the total LPAR CPU is only 59%, and the total CPU on the machine is 81%. So we can see various metrics here. And now we're going to select this row by clicking on it. And we're going to click on the Analyze function. But before we do that, we're going to click on this row, and we're going to click on the Workload button. Now, the Workload button is going to give us a picture of what is running on the machine at this point in time, similar to an RMF report, RMF CPU report. By clicking Workloads, we can now see who is using all of the CPU during this interval. Now, it may be desired that perhaps we want to sort by total percent in descending order here. So we can actually see that when we sort in descending order, that CICS medium is in fact using the largest amount of CPU during this interval. So this is an interesting display that lets us see what's running on the machine at the point in time we're having some problems, and from a tabular perspective. Now, if we go back to the performance table, we can see that we still have this row highlighted, and we have this button called Analyze. Now, VPAT has a variety of AI-like analysis functions that are going to look at hard to ascertain aspects of performance and tuning and make some recommendations. So if we click on this, we're going to see that VPAT is going to give us some information, and it's going to tell us that our LPAR may be constrained by a soft cap, group cap, or defined capacity because the machine is only at 81% busy, but we're seeing very high CPU delays. And there are other things that VPAT is looking at to come up with this conclusion. So based on the data, VPAT's analysis will vary depending on the symptoms and the severity of the problem and the type of problem. VPAT analysis can only be performed on poor and very poor labeled intervals. So if we come back here and we want to graph here, we can see that when we click on graph here, we can actually see that our LPAR's CPU usage in some ways parallels the total KEC busy. And if we're looking at, in fact, performance issues during this period in time, 1959 on the 12th, we can see that we're actually reaching 100% of the machine. So perhaps there is some relation between CPU delay and total busy, but VPAT thinks there's a little more going on. So we're going to look around and see what else we can see right now. So we're going to go back to the performance table, and we're now going to show that we can also sort by delay in this if we want. And when we sort by delay, we can actually see that we have clusters of performance issues around the 1959, 1944, 1929. So surrounding 1920, 2000 at night, we can see that there's a number of things here. If we graph this, we can now also see that since we're in descending order, and we know that our highest CPU delays from that chart were shown up here, that there is some correlation between CPU busy and what we see in terms of CPU delay and workload delay. So we're going to return back now. So let's go back to the performance table here, and let's just sort by date and time to see what else we can see. So we're going to sort by date and time. And we're going to go back into the graph. And I think we should probably zoom into the February 12th since our largest delay was that date. So now we'll look at this. And now we're going to see what other metrics VPAT can show us that may help us identify what may be going on or what we need to look at or to ensure that we're simply configured correctly. So if we look at LPAR LCP, we can see that there were no changes to the number of logical engines assigned to the machine. We can also click on the LPAR weight, and we can see that during the observation period that we're looking at, there was no changes to the LPAR weighting. We can also look at the max available. And this is interesting. This is the dynamically calculated value based on the LPAR's available CPU compared to the CPU usage by the other LPARs and their guaranteed share. So we can see how much CPU was potentially available to our LPAR. And we can see that, in fact, our LPAR does touch the max available at times, and that can be representing some problems if we are truly seeing performance issues that we need to pursue. We can also look at how busy our CICS medium workload is against the CPU busy on the LPAR and on the machine as a whole. And we can see that periods of time, we do see a rise in how busy CICS is at approximately coming up to our problem time. However, if we look at this point, 1959, we can see that workload busy is actually lower. So there's some things to look at here. We can turn off workload busy. We can look and see how busy our zip engines are at the same time. And lo and behold, we can see that CICS does drive some zip engine workload here, but it's lower at the point we're having problems, 1959. So that's probably not representative of an issue. However, as we saw in our early videos, there is the ability for this to represent some level of zip on CP usage. So if this coincided with when our zip on CP usage peaked, this could be representing further evidence for zip capacity expansion. If we look at executed achieved velocities, we can see that, in fact, at 1959, we do have a substantial decline in performance, that our achieved velocity drops dramatically. We can turn on MPL, and we can now look and see that there were more CICS regions running at this point in time than there are other points in time during the day. And this may lead us to some conclusions also. It obviously lets us know that there is an anticipated increase in CICS workload during this period of time. If we look at the PI, which is a WLM performance inference number there, we can see that the PI does in fact rise dramatically at the 1959 level, again, evidencing some slowdown or some potential problem in CICS medium performance at this time. We can look at the SART subchannel rate, and this would let us know if we're seeing any sort of IO related problem or IO related spike, but we don't see that right now. So we're going to reselect total busy and LPAR busy now, and we are going to now show the last interesting display that VPAT lets us see, which is to look at total delay. And if we look at total delay, we can now see that there are a lot of instances where we have CPU delay that we may not be aware of. Instances that VPAT may not have reported as problematic, or instances that VPAT reported as less severe, but we may not even know these are going on. We may be aware of a problem at the 1959 period, but we can see that there is a high prevalence of CPU delay. So let's try to go back and see what's going on here. So let's go back to the performance table, and let's go to the 12th, and let's look at earlier in the day, just to see an earlier performance interval when we were at lower total CPU. So if we're looking here at 4:14 a.m., we can see that our total CPU on the machine is only 71%. And if we click on Analyze on this row for CICS medium, again, we're seeing some reference here that there is potentially a LPAR constraint by soft cap and group capping. So again, there may be configuration issues that we have to further look at. And there's some recommendations here on what to do on increasing capacity or other resolutions that we can take. So this is just further demonstrating the type of analysis that we can do within VPAT. Let's look at one last display that might be of interest for us here and would further evidence what we're talking about. Let's put this into sort by delays, and we're going to go into descending delay order again. This time we're going to graph it again. Only this time we're going to turn on the total delay display. And now we can see that, well, CPU usage, CPU delay is correlated at the high end with high utilization on the machine. But we are also seeing intervals where we have higher than expected CPU delay here, where we have low utilization on the machine. If we look here, we have low CPU delays and even higher metrics than this area here. So again, this is leading us to suggest that there may be more than just some soft capping that we need to look at. There may be a capacity constraint, or there may be other configuration settings that we need to look at that VPAT can be helpful in analyzing. The last thing we're going to display is some further manipulation things that we can do through the performance table. We can click on the All button, as we see here, and what that's going to do is cause VPAT to look through all of our systems, all of our service class data for our observation period, and it's going to pick out all of the intervals that it thinks are poor or very poor performance. Now, as we mentioned before, we've got batch showing up here. Well, we may expect batch to perform poorly. We may expect batch to have higher CPU delays. By definition, if we have multiple batch jobs running that are more than we have engines on the machine, we're by definition going to have CPU delay. So as we scroll through here, we have to be aware of our workloads and what we expect performance to be. But as we scroll forward, we can see that even batch high is having some performance problems. As we look forward, we can see that both CICS and DB2 also are showing some sort of evidence of constraints during this time frame. So this can be very helpful to see that other workloads are being impacted by scrolling forward. Now, when we're in the workload display and we're in the all display panel, since we're only seeing these subset of data, if we click on a parent row, each section of service class data will have a parent row. If we double click on the parent row, it will take us to the same workload performance table as if we had either double clicked in the chart to this service class, or we had gone through the run option to select this service class. And if we cancel out of here, we can even see that in the run panel, there is the all option. And when that's selected, again, you'll see that we get the same exception display that we can drill down into. This brings us to the end of our analyze function. I hope we've seen that we can use VPAT's display functions to understand more of our workload and potentially see more areas where study is needed and possible resolutions to problems are needed. Thank you very much. Please stay tuned for further videos in this series.